Welcome to Optimize 24, the thought leadership event for AspenTech. Today we have with us Rasha Hasaneen, who is the Chief Product and Sustainability Officer for AspenTech. Rasha, welcome.
Thank you. It's good to be here.
It's great to have you inside. We've often heard you on the speaking circuit talk so eloquently about how to make the world cleaner and greener, and the fact that technologies exist to help us find that horizon. So give us a flavor of it. How do we make it happen?
Yeah, no, you bet. And look, I think the idea here is that there are a lot of technologies that exist today that can be applied and adopted more broadly to get us to jumpstart us, let's call it, on the road to net zero. Some of that, for example, is AspenTech's own technology. We have a technology called advanced process control. It's used extensively in the process industry inside factories. We've recently been working with our customers to use that exact same technology, but to adopt it to the upstream business. So using advanced process control and multivariate control to control FPSOs or floating platforms, or to better optimize carbon sequestration upstream or downstream. So ultimately, the ability to use some of these technologies in non-traditional ways can then allow that adoption to happen. And digital technologies are uniquely positioned for that because they're not limited by the physical location. So I can use a technology or use software for one thing, and then all of a sudden I want to do something similar somewhere else. And now all of a sudden I've opened up an entire industry that can get better and better as a result of using those technologies. So for me, I really believe that the pledge that was made at COP28 around doubling energy efficiency is one of the best ones that we've ever seen. The focus on energy efficiency, the ability to use technologies that already exist in some industries, in other industries, to improve that efficiency over and over is really going to jumpstart the journey. I think the other piece around energy efficiency and the application of existing technologies is really going from the asset to the system to the value stream or the value network. The more you can, you're going to reach physical limits on an existing piece of equipment. But there's so much that's lost in between pieces of equipment, for example. Then there's so much that's lost when you go outside the four walls of, let's say, a plant into the value network. If we can figure out how to do those higher level optimizations, you can really unleash so much more productivity. And that is largely untapped today. And again, if we can do that across value networks, as value networks evolve and change as people start to go through the energy transition, making them more efficient from the ground up, we can make such a huge dent in our path to net zero, while newer technologies and innovation come up to speed, can be scalable, can be feasible. We've got plenty of opportunity to accelerate that journey now.
See, you outline a plethora of digital solutions for the path ahead.
Yeah.
We often talk about renewables infrastructure, we talk solar, we talk wind.
Yeah.
But are we, as technologies, as futures, losing sight of the fact that we are not focusing as much on making the grid more resilient and battery storage?
Yeah.
Do you think we're missing a trick there?
I think we started by solving the hardest problem, which is getting efficiency and installability and all of these things of the generation assets. What's quickly going to happen is, one, you hear that those generation assets are intermittent, number one, but number two, there needs to be the grid resiliency to support that. And I think we're starting to see focus on it now. Again, this COP28, more conversation on the grid and transmission lines than ever before. But we're still not addressing some of these core issues. One, intermittency is not just daily intermittency, i.e. the sun shines at night in the morning, but not at night. It's also seasonal, right? The sun shines more in the summer than in the winter. The days are shorter. And so it's not just about battery storage, but long-term storage, seasonal storage. And those have to be solved for these, tripling of renewables to happen. The other thing that's happening is you see a lot more rooftop solar than distributed wind than you've ever seen. A lot of countries in the world have programs around rooftop solar. That distributed nature of energy, our grids are not designed for. And we're not yet armed to go from being consumers of energy to being prosumers of energy. That adds phenomenal amounts of complexity to the grid. And the reality is, in order to manage that complexity, you're going to need digital solutions. You're going to need all of those advancements in AI in order for you to be able to manage just the traffic in the grid. Right now, we're designed for generate centrally, distribute in one direction. Bidirectional transmission, the ability to bill at different rates is there, but the ability to then harvest savings as a prosumer, still working on that. Behind the meter integration, with in front of the meter integration, all of that is going to be critical to us moving forward with.
So you explained in such eloquence how complex a beast the grid is going to become. But specific to AspenTech,
yes,
what can we expect in terms of digitalization to find that, to sort of not just reduce the complexity, but to manage the complexity?
Yeah, well, that's exactly what we do. So we have solutions around distributed energy resource management that allows you to really manage those distributed resources. We're working on solutions around congestion management and being able to predict when a weather event happens, where is the grid most likely to go down? How do I proactively make sure that I have the resources rally to support that, right? To be able to predict the amount of energy you're going to get from renewables and then be able to spin up a peaker when you need it, right? That's exactly what our solutions do today. Our solutions allow companies to manage that complexity without doubling and tripling their resources. We have customers that manage gigawatts of renewables on their grids, and they're doing it from one control room with a couple of operators running our Monarch platform. And again, the more of that we can get out there, the more the grid is going to be ready for all of those renewables coming on and ready for us to be able to take advantage of those storage solutions, the intermittent solutions, as well as firm power and the more traditional types of power.
Let's take the wider energy complex, as it were, and it merits the question. You have enthusiasts for AI when it comes to sustainability solutions and emissions reduction. You have the detractors. You have people who are just plain old scared. You know, so how do you, from your perspective, how crucial a role does AI play in terms of us finding more solutions?
Look, I think it's really interesting, right? Just like any advanced technology, AI goes through a hype cycle, right? We've been working with AI for decades, from back when it was called expert systems and neural networks, right? And I remember a time when neural networks were going to be the silver bullet, right? I remember a time when computer vision was going to be the silver bullet. And all of these things go through cycles. I believe AI is a fantastic tool. AI exists in the digital world. It has to meet the physical world. And so for us, straddling that line between taking advantage of that innovation that's out there in the consumer space, but anchoring it in engineering fundamentals to really start to de-risk some of this technology for our customers who are really worried, frankly, about AI making the wrong decision, right? Who are really legitimately worried about putting a set point into a process that's gonna create a hazardous situation. Those are very legitimate concerns, and the way we do that is we manage the AI with engineering fundamentals. We make sure that we can harness the capability that AI brings in those areas where it can bring it, and that we create, Antonio calls it the guardrails, that are there to make sure that those processes continue to be safe, continue to be reliable, continue to be repeatable, and it allows our customers to have more peace of mind that by applying this technology, they're getting the best out of it without kind of the worst. It keeps the AI, frankly, honest, right?
We've had a broad-ranging discussion on technology, but I guess I got to ask you this question as a sustainability executive to have a more macro spectrum on it, and there is this whole political hot potato of a just energy transition, the whole north-south divide, and how do we bridge the gap? How do we align people's thinkings and not antagonize a few people in the process, and not sort of come across, especially in the West, as that we are preaching to people? So first of all, sum up, what is a just energy transition from your perspective? And secondly, how do we solve this crucial conundrum?
So for me, I think for me, the just energy transition is about making sure that we're not using sustainability as a way to hold people back from advancement and development, especially in emerging and developing economies. So really being just about our expectations of those economies that absolutely want to bring their populations out of energy poverty, out of poverty in general, and have them have the same benefits that we have in the developed world. That's really what the just energy transition is about making sure we're not holding them back by putting additional hurdles in front of them like climate. How do we do that? Well, I always like to think about emerging economies as a real opportunity to do things well from the ground up. In developed economies, you already have a system that's built around fossils. You have a grid that's one way that has to be renovated. In emerging economies, there's an opportunity to leapfrog. And I always use the telephony example, right? We had all of these telephone lines in the developed world. No one thought cell phones. And now all of a sudden, everybody has a cell phone in Africa, right? Because it was a leapfrog. They never laid the lines. And therefore, they could go directly to towers and go directly to the newer technology. How do we make sure that grids in Africa are grids of grids, that the grids can handle distributed energy? How do we then arm villages with not just renewable power, but all kinds of power in a way that's more efficient? We know more today than we did 100 years ago about how to use fossils in a way that's more efficient. How do we take those learnings and make sure that those economies are from the ground up more efficient, greener, and not penalize them for wanting to use their resources? There's ways to use those resources that are greener and more effective, and that way we're being just. They're learning from all of our mistakes, but now we can build it from the ground up, and they can be the case study for then how we build our next grid in the developed world. That, to me, is how you do it, not putting up hurdles for their development.
Challenging but exciting times.
Exactly.
Look, it's been a fascinating conversation. We really appreciate your insight.
Me too, and I appreciate you taking the time to spend with me.
That's Rasha Hasaneen, who is the Chief Product and Sustainability Officer at AspenTech.